question from the Pilot 2012. We're asked to use the graph opposite, or in our case below, to find the gradient of the graph when t equals 10, and also specify what are the units of the gradient. Well, let's start off with finding the gradient of the graph when t equals 10. So first thing we need to do is draw a tangent at 10. So going up from 10, let's draw a line up from 10 so we see where we are, and then draw a tangent there. There's our tangent. What would be nice to do here is draw a triangle so we can try and work out the slope and hence calculate the gradient of that line. So we know it's going to be 10 across here. It's gone from 0 to 10. How far up have we gone? That looks to me to be about, careful with the units here, okay, so 60 there, halfway between 40 and 80, that's halfway between 60, so that's going to be 70. And up here, right, the units are going up in fours, so we're going to say 64, 68, so it's on that next line, so 172. 172 minus 70, giving us a rise of 102. So we can say our gradient is rise over run, so it's 102 over the run of 10, so our gradient is 10.2. So that's part A done. What are the units of the gradient? Well, the units of the gradient were going up in meters on our y-axis and minutes our x-axis. So we're going up in meters per minute. Meters per minute. What practical information do the answers from parts 1 and part 2 give you about the flight? Well, okay, what we can say is that after 10 minutes the balloon is climbing, so positive gradient, and it's climbing at a rate of approximately 10.2 meters per minute. So we can say the balloon is climbing at 10.2 meters per minute. And that's all that's required for part B of this question.